Okay, apologies. Admit all Siti Salwani and Kartik baru join. Welcome. Why are you not sharing? Ah, just okay. Alright. So hari tu the other day saya dah go through this. So these are some of the tests yang kita buat lah dalam QC. Kita nak determine the identity, kita nak determine the percentage of the content, kita nak tengok dalam the whether the tablet contains any impurities, any substances lain yang kita dah kenal pasti ke. Okay, so these are the things yang kita perlu ascertain. Macam dalam dokumen yang saya tunjuk tadi ada 9 test kesemuanya. So each of the test akan kita nak kaji different aspect of the drug lah. Macam dia punya pH ke, dia punya average tablet weight, dia punya kekerasan pun kita test. Okay, so these are to ascertain untuk menjamin. The goal, remember the goal untuk kita perform all these tests adalah to ascertain the safety and the efficiency of the drug. So when we perform analysis, this is the some analysis kita perlu buat menggunakan instrument. So bila kita nak pilih instrument, these are the 5 things that we need to consider. Okay, it starts with accuracy and precision. So these two takes top priority. Sebab without accuracy and precision, kita tak boleh nak jamin keselamatan. Kita tak boleh nak kata kita punya result tu betul-betul bagus. Okay, kalau kita tak boleh nak jamin our results is good, so kita tak boleh nak jamin the safety and the efficiency of the drug. So that's why when you want to choose analytical instrument, these two takes top priority, accuracy dan juga precision. The third one is efficiency, and the fourth is standardization, and lastly cost. So sekarang saya nak fokus on what is accuracy and precision. So to explain that, kita akan masuk dalam this subtopic QC. So what is QC? Quality control. Basically, kat sini saya secara kasarnya explain QC is basically a method to control error in analysis. Bila kita perform kerja, tak kira lah kerja apa pun, bila you cook in the kitchen. Okay, katakanlah you go into the kitchen, you want to cook a recipe. You might, even if you follow follow a recipe that you download online, kamu buka YouTube cooking recipe, and you might perform measurement tak betul. Dia kata ambil secubit garam, maybe you take more than satu cubit. Okay, maybe cubitan kamu tu terlalu besar dan cubitannya. Okay, so we have to accept that errors could always happen bila kita buat kerja. So this is even more important in instrumentation analysis, because errors could affect our efficiency dan juga accuracy. So that's why bila saya cakap tadi, accuracy and efficiency is the most important thing bila kita perform analysis. Okay, because kerja, our main goal, our main objective is to jamin keselamatan pesakit bila kita makan ubat kita, and also kita nak jamin ubat kita berkesan. So when we perform analysis, that's our goal. Bila kita tak boleh nak control error, then we fail in our goal. So QC, dia ada satu sistem. Basically, kita perlu follow the system so that we either eliminate the risk of error ataupun kita kurangkan the risiko untuk perform that error. Okay, so these are the types of errors that we have identified. Kita ada gross error, systematic dan juga random. So the definitions for these three, untuk gross error, it means a major breakdown in the process. Contohnya bila kita perform a test, kita perlu mix, kita perlu prepare solution. Okay, maybe solution yang kita prepare tu tertumpah, and then from that solution yang tertumpah tu, we prepared the wrong dilutions ataupun instrument pula rosak. So from top to bottom, they are major breakdown in the process kita buat kerja tu. So daripada awal sampai habis salah. So this is called gross error. The next type of error adalah systematic. So this is error in making measurements. Before we go, saya rasa lebih it's better kalau saya explain a bit about the actual process. So I want to show you this document again. Okay, so this is the document, the standard test procedure untuk chlorpheniramine. Okay, so kalau saya nak test, saya nak perform assay test, this is the document I will refer to lah. Okay, so assay test adalah satu test yang mana kita nak tentukan dia punya kandungan of the active ingredient in the drug. So dalam this chlorpheniramine tablet, kita ada 4 mg of the active ingredient. So in chlorpheniramine tablet ni, dia punya active ingredient we claim to have 4 mg. So this is the content of the active ingredient. So if you don't know, active ingredient is the substance that makes a drug. Without active ingredient, ubat yang kita makan tu will not function as ubat. Okay, so it is the most important that the content of the API is up to standard. So kalau kita claim the content of the drug is 4 mg, before kita boleh jual the drug to the public, kita mesti jamin dulu, kita mesti tentukan betul ataupun tak betul dos dia adalah 4 mg. So that is assay test. Okay, so bila kita nak perform assay test kat sini, dia ada release limit. So release limit ni basically means kalau kita nak release this batch of tablet, dia punya bacaan kandungan dia mestilah within 95 to 105%, ataupun dari segi berat dia, kandungan API dia mestilah 3.8 hingga 4.2 mg per tablet. Okay, so kalau kita claim dia punya kandungan active ingredient adalah 4, so this is the acceptable range. Kalau kita buat one batch, berat the amount of active ingredient yang kita dapat 3.9, masih lagi diterima. Okay, so this is the acceptable range untuk release to the market. So kalau saya nak perform this test, dia ada step by step lah. Sorry 1 minute, banyak bunyi lah phone, saya nak mute. Okay, so kalau kita nak perform this assay test, these are all the things lah yang diperlukan. Dia punya apparatus, semua dia bagi kaedah step by step, macam mana nak buat pun dia senaraikan kat sini. Okay, bahan apa yang diperlukan, reagent, apparatus. So here you can see kita perlukan methanol, hexane sulfonic sodium, salt, acetic acid. Glassware kita perlukan adalah volumetric flask, pipette dan juga beaker. So apa jenis solution yang kita nak sediakan also ada disenaraikan. So kat sini ada, kita kena prepare solution A. Macam mana nak prepare solution A, buat ni, follow step by step, and then dilute, and then adjust the pH, and then that's your solution A. Okay, but I don't want you to get hung up over that. Yang saya nak kamu tengok adalah bahagian standard preparation. Okay, so anytime you want to perform an analysis, kalau pun nak buat assay test especially, you will need to prepare 2 main solutions. Okay, the first one is standard solution and the other is your sample assay solution. So your sample assay preparation ni adalah your tablet lah. Kalau saya nak test chlorpheniramine tablet, saya perlu prepare a solution of that tablet. So kat sini kalau kamu tengok, it says here you need to powder 20 tablets. So take 20 random tablets, grind dia jadi powder, and then weigh 90 milligram of powder tablets, and then transfer dalam volumetric flask, and then dissolve in solvent. So you have your assay sample solution. So solution inilah yang kita akan guna untuk kita compare dengan the standard solution. So the standard solution is another solution that you need to prepare, and it only contains the same substance as the active ingredient. Okay, so kita nak compare, we want to identify and determine the amount of active ingredient yang ada dalam chlorpheniramine tu. So basically, kita akan compare the solution of the tablet yang kita prepare dengan a solution that is only containing the active ingredient, iaitu chlorpheniramine malate. So nak prepare this standard solution, you weigh 100 milligram of chlorpheniramine malate working standard, and then dissolve in solvent. So both of this solution kita akan analyze using HPLC. Okay, so how are we going to nak kenal pasti? So dalam this on my screen right now, kamu nampak ada dua graph basically. Okay, so this is a chromatogram of the standard solution, and this is the chromatogram of the sample solution. So using HPLC, kita boleh detect the presence of the substance yang kita prepare dalam solution dari itu. So for example, dalam this standard solution punya chromatogram, we detect the substance here, this tall peak here. So this is chlorpheniramine malate. We can confidently say this is chlorpheniramine malate because dalam solution yang kita prepare tadi, we only timbang 100 milligram of chlorpheniramine malate. Kita ada bahan yang lain. Okay, berbeza dengan our sample solution, dalam kita punya tablet tu is a mixture of ingredients. Kita ada active ingredient, other excipients lagi dalam tu. So akan ada more kita tak boleh nak say for sure peak yang kita sediakan tu adalah yang kita jumpa ni adalah chlorpheniramine. So bila kita compare this solution of this assay sample solution dengan the standard solution, and we find out that the time it takes for this peak to form adalah sama, so we can make a conclusion that this peak yang ada dalam sample assay solution ni adalah chlorpheniramine malate. So we have identified the active ingredient dalam kita punya pharmaceutical drug tu, dalam chlorpheniramine tablet. So bila kita dah identify, kita boleh tentukan the amount using this formula lah. Okay, so this is how we perform an assay test. Where is it? Kenapa putih saja? Okay, but the thing yang saya nak highlight kat sini adalah cara-cara kita prepare these solutions. Okay, so here when we perform assay test, basically we prepare two solutions, standard dan juga your sample. Okay, in the standard solution, kita only prepare a solution that only contains chlorpheniramine. In our sample, we prepare a solution of our tablet lah, chlorpheniramine tablet. So bila kita buat test, kita takkan prepare just one standard solution dan juga one sample solution. This is because remember dalam bila saya tanya what is QC, saya kata it's a method to control error kan. So bila kita prepare just one solution of standard and juga sample, we have no way of monitoring the efficiency of our work. Kita buat kerja ni, kita measurement kita ni betul ataupun tak betul. We have no way to check ourselves kalau kita prepare just one solution each. So to solve this problem, kita akan prepare duplicate solutions. Solution meaning kita akan prepare, usually kita akan prepare 2 standard solutions dan juga 6 sample solution. So meaning kalau dalam this document tadi dia suruh untuk sample solution, Dia suruh timbang 90mg of powdered tablet. So what we do adalah apa yang kita buat adalah kita akan timbang, kita akan prepare a solution sebanyak 6 kali. So we have here volumetric flask, kita prepare 90mg, timbang 90mg of the tablet and then top up dengan solvent. So this is solution number 1 for sample. Dan kita prepare lagi the second sample, 90mg juga. The same preparation method. Okay, there's no difference. So for all 6 of our sample, dia disediakan dengan cara yang sama. 90mg 4. Sorry lah, saya tak cantik. Okay, 5 dan juga 6. 90mg. So the purpose, kenapa kita prepare sampai 6 solution? This is so that we can track kita punya our work. It is accurate and precise. Okay, so how do we do that? Kita akan tengok how far it deviates. The final result, kita tengok the final result, how far it deviates from our goal. So our goal here kat sini adalah kita nak dapatkan dia punya content of the the content of the active ingredient within this range, 3.8 sampai 4.2. So katakanlah I prepare 6 of this sample, and then saya dapat bacaan for the first one. Saya dapat remember our goal is 3.8 sampai 4.2. This is our goal milligram. So katakanlah bila saya dah prepare the solution, I run it in HPLC and saya dapat untuk the first solution, katakanlah saya dapat 3.9 mg. This one I get 4.1. This one I get 4.0, 4.2, and then this one suddenly 3.5, and then this one is 3.6. So I can see a pattern from the final results. Okay, this is the final results of my 6 sample solution. So our expectation is patutnya dia punya bacaan lebih kurang sama lah, because cara preparation dia sama. Kita timbang 90mg and then kita dissolve with 25 ml solvent. Ini pun sama, dissolve in 25 ml solvent, 25 ml, 25 ml. All of them are prepared using the same method. So our expectation is dia punya final result should be almost the same. So kalau in this case, in my example ni, ada deviation. So this is deviation yang paling besar lah, 3.5 dan 3.6. Because 3.9 ni jatuh dalam range, 4.1 also within range, 4.0 also within, 4.2 also within. Tapi 3.5 is less than our lower limit, 3.8. 3.6 is also lower. So from here kita something is wrong. So this batch has failed the test. So saya boleh investigate balik using, because saya nampak pattern ni dalam the final result. So when we prepare duplicate solutions like this, we give an options for us untuk investigate kalau kita ada problem like this. Okay, kita boleh backtrack, kita boleh look back in our preparation kat mana tersilap. Did we measure this wrong? Ataupun kita timbang tak betul. Okay, ataupun maybe tertumpah somewhere, we don't know. So usually the protocol is bila dia ada tak pas macam ni, kita kena repeat this test. So kita prepare lagi sekali 6 solution using the same method. So kalau if we prepare the second time, dapat okay 3.9, 3.9, 3.9, 4.0, 4.0, 4.1. So semuanya within range. So maksudnya in the first time bila kita buat dia tu, kita ada perform something wrong. Okay, maybe kita instead of timbang 90mg, maybe some of the samples kita timbang tu tertumpah. So actually yang tertimbang hanyalah 80mg only. This one also 80mg only. That's why bacaan dia rendah. Okay, so This is error lah yang kita perform yang mungkin kita tak perasan. Okay, measurement error. So that's why the importance of that is the importance of kita prepare duplicate solution, so that we can monitor ourselves untuk kurangkan risiko we perform any of these errors. So that's why saya nak explain dulu this part tadi before kita go through the types of errors. So dalam this slide saya ada nak tukar balik. Okay, systematic error kat sini saya tulis error in bila kita perform error in making measurements. Dia punya error tu kita repeat the same error, kita repeat again and again. So that's why saya bold the word repeated here. Repeated inaccuracy in making volume measurement. Repeated failure to zero the instruments prior to analysis. Okay, macam kat sini lah. Dalam saya punya drawing tadi ni. Repeated error. Saya instead of kena timbang 90 mg, I only timbang 80. Kat sini pun saya timbang 80. So I repeat the same mistakes for this last two solution. So that's why dia punya final result lari. Okay. So the next type of error pula adalah every time I have to change adalah random error. So this kind of error dia punya pattern is very random. Okay, we observe the patterns in our final result. So random inaccuracy in making volume measurement ataupun random failure to zero the instruments prior to analysis. So kenapa kita kena tahu different types of error? Because bila kita assess the error that we no how do I put this? Because there is a close relationship antara the types of errors that we make dengan the accuracy and the precision that we yang kita buat lah masa kita perform analysis tu. So what is accuracy and juga precision? Kat sini saya tulis untuk accuracy is the ability of a person ataupun instrument to measure or calculate the value closest to the standard value. So to explain this, kita tengok balik saya punya ni. So in this example, yang kecil sikit. Okay. Dalam example ni, so accuracy is the ability of measuring ataupun calculating a value closest to the standard value. So what is a standard value? So in the case of my example tadi, our standard value adalah 3.8 to 4.2. Okay, this is our standard value. Kita nak measure the amount of active ingredient chlorpheniramine tadi itu to be within this range. So kalau saya prepare 6 solution, so all of 6 solutions should be within this range. Okay, so the first one within the range. The second one also within the range. The third one is within. The fourth is also still within. Tapi the fifth and the sixth one is below the limit 3.5 dan 3.6. So that's why kita boleh buat conclusion this is an error lah. Kita buat error somewhere bila kita perform, bila kita prepare this two solution. Okay, so bila kita boleh measure the value closest to the standard value, that means we are accurate. Ini tak accurate. Okay. Precision pula adalah the ability of the person ataupun the instrument untuk repeat the same results again and again, repeat the same measurements again and again. So dalam contoh saya ni, kalau saya prepare 6 solutions, if I want to be precise, I should be able to repeat the same measurements again and again. So in this case, saya hanya boleh repeat the same results sebanyak 4 kali out of 6. Lagi 2, the final 2, I fail. So that means I am not precise. Tapi bila saya repeat the test the second time, I get 3.9, 3.9, 3.9, 4.0 and 4.1. So in the second test, I am precise. I'm able to measure the value again. Okay, itu beza antara accuracy dan juga precision. So in analysis, both are important. You cannot be accurate only tapi tak precise. You cannot be precise only but not accurate. So to demonstrate that, kita tengok balik our lecture note in the slide in the next. Okay, so in this slide, saya tunjuk kita compare analysis between 4 students. Kita nak tengok the importance of precision dan juga accuracy. So in this example, kita ada 4 students and all 4 of them were to prepare, need to perform an essay test on paracetamol. So they need to prepare 5 solutions. And the standard goal adalah 100% lah. Kita nak make sure the content of the paracetamol is 100. So this is, dalam graph ni kamu nampak ada tarik satu line. This line here mark the 100% of the content of the PCM. So kita tengok student number 1. Okay, it says here student number 1 is precise dan juga accurate. So why is the student precise and accurate? Kita tengok dia punya 5 solutions. Solution yang dia sediakan all are within 100%. So that means kelima-lima solution yang dia sediakan accurate. Kita dapat measure close to 100 and dia boleh repeat the same measurements again and again. So that's why student ni precise dan juga accurate. Okay, berbeza dengan student number 2, dia precise tapi inaccurate. So you take a look at dia punya 5 preparation, 5 solution yang dia sediakan. The bacaan yang dia dapat adalah within 95 to 97 kat sini, tak close to 100. So dia tak dapat jadi accurate, dia tak dapat bacaan yang tepat. It's not accurate, tapi dia precise sebab dia boleh repeat the same measurements again and again. So this is the importance of kamu kena ada dua-dua, precise dan juga accurate. Walaupun kamu precise macam student number 2 ni, tapi kalau kamu tak accurate, you fail 50% of the goal lah. Okay, student number 3, dia imprecise and inaccurate. Okay, dua-dua dia tak. Okay, tak ada satu bacaan pun close to 100 and he is unable to repeat the measurements again and again. So kita boleh assess kenapa this student kenapa this student precise, student number 2. So maybe he perform a error in measurement bila dia prepare solution ataupun bila dia buat dilution. Dia kena go back lah, investigate balik. Okay, and for student number 4, dia imprecise, tidak jitu tapi dia accurate. Accurate in this case because ada one of the solution dia dapat 100%, but the other 4 is all over the place. So you can see the pattern yang kita boleh nampak from these 4 students. Okay, kalau dia precise and accurate, dia punya bacaan will tertumpu pada satu spot only. Kalau dia precise tapi inaccurate, dia akan tertumpu pada spot yang salah. Our goal is 100, tapi di student number 2, dia punya all 5 solutions is focused on 96-97%. Kalau dia imprecise dan inaccurate, dia punya bacaan will be all over the place. Okay, kalau dia imprecise tapi dia accurate, it will be all over the place, tapi one or two of them akan ada lekat lah, satu close to 100. Okay, so that is how kamu bezakan antara accuracy dan juga precision. Okay, so let's I want to do in 5 minutes saya akan datang balik and I'll share the link for quizzes. Okay, so link for this quiz is saya ada share dekat chat room. Where is it? Okay, so just click on the link and join. Boleh join tak? Ke ada problem? Boleh lagi nak join? Okay, saya mula dulu, yang selebihnya boleh join. Okay, thank you. Sorry, ada lagi 2 orang. Okay, so kita mula dulu. Lagi seorang tu boleh join. Mana boleh join. Okay. Question ya. Let's lagi one more. Yeah, after this kita akan go over the questions. Question ni disconnected ke? Ke kamu tengah try lagi? Okay. So after everyone finish, kita akan go over the questions. Hmm. Okay, sorry, mana location ni? Okay, location ni kita stop dulu. Kita akan we'll discuss it. Kita review all the questions. Okay. Okay, so let's review. So question number 1 kat sini, it is a measure of how close. Oh, less than half of you got it right. It's a measure of how close measurements come to each other when they are made in the same way. Jawapannya adalah precision. Okay. Ayat yang dia bagi ni pun macam very confusing. Basically apa yang dia kata adalah kalau kamu ada a series of measurements, and it means when all 5, katakanlah you have 5 sets of measurements, you measure the same thing and all of them are close to each other, so that is precision. Okay, when you bila kita buat satu ukuran and then we can measure the same measurements again and again, and that means you are precise. So I admit dia punya susunan ayat ni pun macam berterabak. Okay, but that's what it means. Precision, the ability of a person ataupun the instrument yang kamu gunakan to measure the same measurement again and again. This question, based on the data provided, which student has the most precise data? Kita ada student A, B and C. So the most precise adalah student C. So kat sini dia measure melting point of sucrose. And it says here the melting point of sucrose is 185 degrees Celsius. So kamu tengok balik, the definition of precision adalah the ability untuk measure the same value again and again. Okay, ataupun inilah similar values lah again and again. So student C ni kamu tengok dia punya measurement of the melting point 181.2, 182.0, 181.7 and 181.6. So all 4 measurements very close to each other. Kamu bandingkan dengan student A, the first one is 183.5. Boleh tak saya nak besar kan sini? Measurement number 2 185, number 4 and number 3 184. So dia punya measurement taklah jauh sangat, tapi this one student C is more closer to each other. Student B 190, 183, 187. So sangat jauh lah dia punya deviation. So that's what that is why student C has the most precise data. How close the measurement is to the accepted value is called accuracy. Okay, the ability of a person ataupun an instrument to measure the value closest to the accepted ataupun standard value is called accuracy. So ramai. Okay, 2/3 of you got it right. So soalan ni, this is basically a trick question. Okay, dia tanya kat sini the bullseye demonstrate. You have a dartboard here. Dia tanya bullseye kat tengah ni demonstrate what? Jawapannya adalah mana ada bullseye kat sini? Tapi low accuracy and high precision. So kat sini dia punya attempt dekat board ni semua tertumpu on this spot right here. Okay, low accuracy because kalau dia dapat kat tengah-tengah ni, that is accurate lah. Then this is the target value. Kita target bila kita baling dart, bila kita shoot an arrow, this is our target, the center, the bullseye. Tapi this person, all of his attempts semua tertumpu at this bottom left spot here. So dia tidak accurate, low accuracy but high precision because all of his attempts tertumpu in one spot. This one, apa punya assessment? This is high accuracy and high precision. Okay, dia sangat accurate. Semuanya jatuh dalam this white center. Students measured length during a science experiment. They got ni kamu kena calculate. Basically dia tanya percent error. So kalau kamu nak calculate percent error, percentage of the error that you make in measurement, kamu ambil the highest value dengan the value yang low, tolak 14.25 tolak 12, and then that value bahagikan dengan 14.25. So darabkan dengan 100. So you will get 15.79. So if you take 40.25 tolak 12, and then you get an X value. So X tu bagi dengan 14.25 darabkan dengan 100. So kamu kena bagikan dengan the actual measurement. Okay, bukan bagikan dengan the smallest value. Next one, Jessie estimates the weight of a cat to be 8 pounds. Ini sama macam tadi. Okay, and but the actual weight is 10 pounds. So ambil 10, tolak 8, dapat 2, bagilah dengan 10, dapatlah 20%, darab dengan 100. Okay, if you want to calculate the percent error, you find the difference between the two measurements and bagikan dengan the actual measurement, darabkan dengan 100. Which is more precise? Jawapannya yang paling ni lah, 4.300. Next question, describe the accuracy and precision of the image. So kat sini dia tak accurate langsung. None of the attempt fall dekat tengah-tengah sini. And not precise. And dia tak boleh, dia punya attempt berterabur. So kalau dia punya attempt tak ada pattern yang or fall within the same spot ataupun fall close to the center, and dia tak accurate and tak precise. Next is how close the measurement is to the true value is called accuracy. Okay, this is a repeat lah, jadi kita dah buat kan. So volume ini adalah 48. So bila kita tak nak senggatan macam ni, senggatan dia hanya ada 3 saja, 40, 50 dan 60. So when it falls close like this, kamu tak boleh nak assign titik perpuluhan, because kamu tak tahu, you don't actually know. So the best you can do adalah kata 48 milliliter. Next, it's different when you have senggatan like this. Okay, when you have more graduation, kamu boleh inilah accurately determine dia punya measurement. So in this case, jawapannya adalah 63.5. So 60, 61, 62, 63, and this meniscus falls between 63 dan 64. So it's 63.5. This image is an example of accuracy only, sebab dia tidak precise. Okay, dia punya 5 attempt dia jatuh all over the place. Satu saja jatuh dekat tengah-tengah. So dia accurate one time. Precision tak langsung. Okay, sometimes you can be accurate but not precise. Kamu kena assess lah kamu punya attempt tu macam mana. Which student is the most precise? Kita tengok siapa yang bagi lebih more data kat sini, 15.35. So sini ada 2 titik perpuluhan compared to the other two. Sini ada 1, sini tak ada langsung. A set of data are all close to each other but they are not close to the actual value. So this can be described as precise. Bila a set of data is not close to the actual value, that means they're not accurate. But when they are close to each other, they are precise. A set of data are all close to each other and they are close to the actual value. That means both lah, they're precise dan juga accurate. Okay, so overall I think most of you got for all questions except for calculation dari tu ramaikan tu question 11 and 12. Okay, but hopefully you guys understood lah what's the difference between accuracy and precision and how they relate to the types of errors. Okay, so I think that's it for class today. Nanti saya akan share the link for assessment 1 dekat dalam Google Classroom. Semua boleh tengok dekat situ. Saya akan post. Watch out for the announcement lah dalam Google Classroom nanti. Okay, semua ada any questions tentang accuracy and precision so far? Okay, so kalau tak ada apa-apa, thank you. See you next class. And then kita ada satu kelas kena ganti. Nanti saya akan pilih a date and then confirm with you guys. Okay, terima kasih semua. Okay, thank you.